In this video, we're going to illustrate how the call and return operations work in the x86 64-bit architecture. These two operations are a very important part of the procedure call mechanism on the x86, but only a part. Let's start with a larger picture. Consider the very simple C function plus shown here. We might call this function elsewhere in code, say from our main routine, as shown here. The C calling mechanism has to accomplish several goals. First, the call to plus must transfer control to the function, but also keep track of the current location within the calling environment so that execution can continue at that point after plus returns. Second, the calling environment must pass to plus its two parameters. Third, function plus must pass the value it returns back to the calling environment. Finally, execution should resume at the appropriate point in the calling environment after plus returns. When the C code is compiled into x86 assembly, all of these goals must be taken care of. However, not all of them are accomplished by the x86 call and return statements, which are the focus of this video. Some are handled by various x86 calling conventions. For example, parameter values are passed to the called routine by the calling environment placing them into designated registers, or by pushing them onto the runtime stack prior to the call. The called routine, in this case plus, knows to look for its parameters there. The returned value is passed by the called routine back to the calling environment by placing it into the designated register RAX. The calling environment expects to find the returned value there after the called function returns. There's one further aspect of the procedure calling mechanism that's worth mentioning. Since the registers are global and accessible to all routines, there's a set of conventions that routines follow to preserve register values across calls. Depending on the register, either the caller or the callee is expected to save and restore the register's value. We'll discuss these aspects of the procedure calling mechanism only in passing in this video, but let's get on to call and return. The purpose of the x86 call and return operations is only to transfer control, first to the called routine and then back to the calling environment. Shown here is a small portion of the x86 code generated by the compiler for our simple C example. We've also shown possible addresses for each assembly statement. The linker has placed function plus into memory starting at location 400546 and placed function main at location 40054A. Now suppose that we're in main, poised to execute the call plus statement. Notice that that statement is at memory location 400558, which means that the program counter has that value. Let's see what happens as execution proceeds with the call statement. Call does two things. It records the return address and transfers control to the called routine. So first, we need to save the return address for this call. When the call to plus returns, we want to continue executing at the following statement. That is, the move-L statement immediately following the call. To accomplish that, we need to save the address of that statement, namely 40055D. Note that it wouldn't do to save it in a register, since, in general, we don't know how many other procedure calls might occur before we return. Were we to save the return address in a register, it might be overridden by a subsequent call. Instead, we save the return address by pushing it onto the runtime stack. Prior to the call, the stack value is pointing to whatever value is on top of the stack. Here, we're not interested in that value. We push the return address, 40055D, onto the stack. And by the way, we have separate videos on pushing and popping values on the runtime stack. If you're unfamiliar with the details of how that happens, take a look at those. To finish execution of the call statement, we place the starting address of the called routine plus, namely 400546, into the program counter. This ensures that we will continue execution in the plus routine. Recall that the calling environment will have passed the arguments to plus by placing them into appropriate registers. Plus now continues executing, ultimately computing a value to return to the calling environment and placing that into register RAX. Eventually, execution within plus reaches the return statement. At that point, the stack and PC should appear as shown here. Notice that the PC indicates we are poised to execute the return statement within plus, and the return address from main is on the top of the stack. By the way, it's very important that if plus had pushed some values onto the stack, then it cleaned up after itself by popping those values off. The calling mechanism won't work properly unless all routines follow the stack discipline. To return execution to the calling environment, we pop the return address off the runtime stack into the program counter. The resulting state is shown here. This assures that execution continues at the return address, namely the address of the movl statement following the call statement in main, which is precisely what we want. The x86 call and return operators described in this video are part of the delicate dance that comprises the x86 procedure call mechanism, which also involves parameter passing, value return, and preserving register values across calls.